Okay, so next we will see previous year question papers based on heat exchanger topic. Okay, we will see the questions one by one. First question, the mathematical expression of NTU in a heat exchanger. So in the video lecture about the theory heat exchanger, where we have seen the formula for NTU, which is UA by C minimum. That is the formula for NTU. So that is the solution for that. Next, the LMT. So what are the questions that I am showing you? All are asked in the examination only. All questions previously asked in so many states. So I am just seeing everything and listed out, and I am just showing it based on the topics. Okay. Now heat exchanger. Another question, the LMTD of a heat exchanger with delta T1 and delta T2 being temperature difference between hot and cold fluid. So they are asking the formula for the LMTD. Like we have seen, LMTD the formula is equal to theta 1 minus theta 2 divided by log of theta 1 by theta 2. Here instead of theta 1 they have listed as delta T1 and delta T2, and so that answer is delta T1 minus delta T2 by ln of delta T1 by delta T2. Okay, so this is the equation. Formula you should always remember in the heat transfer. This is the LMTD equation for the heat exchanger. Okay, so here one more option also you please remember. Sometimes to confuse you, how they will ask the question means they will ask, they will not give this one. Okay, what they will give? They will give delta T minus delta T1 divided by ln of delta T2 by delta T1. This is how they will give you. But sir, you have told me that only the formula for the heat exchanger is delta T1 minus delta T2 by ln of delta T1 by delta T2. But in this nothing is given like that. Okay, so instead of this option B, you take this is the option. Okay, so in this you will remember in the examination hall only this formula, delta T1 minus delta T2 by ln of delta T1 by delta T2. But if you see this in the options, it is not given. So what you will do, you will get confusion on that particular time. So you don't get confused. Instead of this, if you substitute this also, the same answer you will get. So this and this both are equal. Either this option they will give in the answer options, or they will give this, so that it will be correct. Both are correct. Okay, either delta T1 minus delta T2 by ln of delta T1 by delta T2, or delta T2 minus delta T1 by ln of delta T2 by delta T1, both are correct. Okay, so but here you see delta T2 minus delta T1 by ln of delta T1 by delta T2. This is not correct. Here it should be 2 by 1. Okay, so these all problems whatever I am solving, if you directly watch this video you will not understand anything. So first you have to see the theory session about this heat exchanger, then you come to the problem solving session. Okay, so the students who watched the theory session about this, they will easily understand what I am trying to mean. Okay, next, a counterflow heat exchanger. The hot fluid cooled from 110 degrees Celsius to 85 degrees Celsius, cold fluid heated from 30 degrees Celsius to 60 degrees Celsius. The LMTD is. So what is the LMTD formula? What is the LMTD formula? LMTD formula is delta T1 minus delta T2 by ln of delta T1 by delta T2. Okay, so let us take, this is a what type of heat exchanger? First you see, it is a counterflow heat exchanger. Then you just make a graph for counterflow heat exchanger. In counterflow heat exchanger, both the fluids move in the opposite direction. Let us take, this is the hot fluid moving from here to here, and it is given as it is cooled from 110 degrees Celsius to 85 degrees Celsius. So it is entering at 110 degrees Celsius and leaving at 85 degrees Celsius. Cold fluid is heated from 30 degrees Celsius to 60 degrees Celsius. So it is entering at 30 degrees Celsius and leaving at 60 degrees Celsius. Right? So now you see, what is the delta T1? I have given. Here, what is the difference between the delta T1 and delta T2? So if you see 110 minus 60 and 85 minus 30, so the formula is delta T1 minus delta T2 by ln of delta T1 by delta T2. Okay. Now 85 degree 110 minus 85, sorry, it is not 110. Okay. So if you take that, if you substitute that in the equation, then you will get the answer as 50. If you substitute that, then you will get the answer as 50. Okay. Next, which of the following correctly represents the counterflow heat exchanger? So like I have drawn on the graph here that I have erased. So counterflow heat exchanger means fluid direction will be opposite. It is moving from here to here and it is moving from here to here, and this is also same. Here also it is moving from here to here and here it is moving from here to here. So if you see this both, you will get doubt which one is correct. But you have to always remember there will be some variation in the temperature. Curve should not be a straight line. If the line is straight, then there is no changes in the temperature. So the answer C is correct. Next, what does NDU indicate? NDU is mainly for all those things, but main important thing NDU is used to find out the size of the heat exchanger. Okay. Next, hot fluid enters at 105 degrees Celsius, leaves at 30 degrees Celsius. Cold fluid moves in opposite direction, enters at 15 degrees Celsius and leaves at 80 degrees Celsius. Okay. Now you see this. Okay. In this, they have not clearly mentioned this is a counterflow heat exchanger, but instead of that they have given it is moving in the opposite direction. Opposite direction means this is the counterflow heat exchanger. So here I have drawn the graph. Hot fluid is entering at 105 and leaving at 30 degrees Celsius. Cold fluid entering at 80 degrees Celsius, leaving at 15 degrees Celsius. What is the formula? Delta T1 minus delta T2 by ln of delta T1 by delta T2. Okay. So delta T1 minus delta T2 is how much? So delta T1 is 25, delta T2 is 15. So 25 minus 15 is 10 by ln of 25 by 15. So if you substitute, the answer is, they have not given the numerical value. Instead of that, they have directly given 10 by ln of 5 by 3. So the answer is 10 by ln of 5 by 3. I hope that you are easily understanding. I no need to explain in detail about substituting the values in the formula. If you substitute, you will directly get, like previous problem also I told you like that only. You just see the formula. What is the formula for this? What is the formula for this? Actually, what I have already told in the video lecture, LMTD equal to theta 1 minus theta 2 by ln of theta 1 by theta 2. This is the formula for LMTD, right? So here theta 1 means the temperature difference between this. This is theta 1 or delta T1. This is theta 2. It is very simple to solve. So theta 1 is difference between this, which is 25. Minus theta 2 is difference between this, which is 15, divided by ln of, what is that? Theta 1 is 25 by 15. So if you simplify, how it will become? 10 by ln of 20 by 15. May I put here what they given? 5 by 3, 5 table. So the answer is 10 by ln of 5 by 3. If simplify, I simplified. If they give the numerical value, the answer is 19.57. That is the LMTD value. Okay. Next. This is most important problem. If one of the two fluid flowing through a heat exchange of N2U is equal to 2, the effectiveness of the heat exchanger. Okay. So this you remember, the effectiveness if the 100% in parallel flow, if the effectiveness is 100% for the heat exchanger, then the effectiveness for the parallel flow formula is 1 minus e power minus NTU. If this is 50%, then the formula is 1 minus e power minus 2 NTU by 2. That is for parallel flow, and for counter flow, for 100% effectiveness formula is 1 minus e power minus 2 NTU, and for 50% effectiveness is equal to NTU by 1 plus NTU. And if you want to say that in terms of NTU, then NTU you can say which is equal to effectiveness by 1 minus effectiveness. So either you can solve by effectiveness. If they give you NTU value in the question paper, then they will ask you to find out the effectiveness. So if you substitute, you will get the effectiveness, or otherwise they will give the effectiveness value so that you can find out the NTU. Okay, they will give either NTU or effectiveness for 50% of effectiveness in the counter flow heat exchange. Just remember only the formulas. Okay, now you see the question. What they asked us? They asked us, if one of two fluid flowing through a heat exchange of NTU equal to 2, the effectiveness of the heat exchanger. Okay, so you take parallel flow. They have not mentioned what type of flow you consider as a parallel flow. For parallel flow, you have to assume that is 100% effectiveness. So the 100% of effectiveness is equal to 1 minus e power minus NTU. So this formula if you take, you have to write 1 minus e power minus NTU. Here NTU value is given as 2. Then what will be the answer? 1 minus e power minus 2. If you remember this formula, you can solve this question. Okay, so remember these formulas. Okay. Next, LMTD of counter flow heat exchanger is compared to parallel flow is higher. So that I already told you while I am taking the theory session for this heat exchanger, I have already written always effectiveness of the counter flow is higher than effectiveness of the cross flow and effectiveness of the parallel flow. This you remember, I already told you in the theory session. So always effectiveness of counter flow will be higher than the parallel flow and the cross flow. The counter flow heat exchanger, hot gases enters at 250 degrees Celsius and leaves at 100 degrees Celsius. Cooling air enters at 50 degrees Celsius and leaves at 80 degrees Celsius. Find the effectiveness of the heat exchanger. Okay, so this is little bit different. Earlier we solved the LMTD equation. Now here they are not asking the LMTD. Instead of LMTD, they are asking the effectiveness of the heat exchanger. Okay. Now, what is the formula for effectiveness? Effectiveness formula is actual heat transfer by maximum heat transfer. Okay. So, there are two formulas to find out the effectiveness of the heat exchanger. First formula is when they give only the temperature. There is some concept behind that. No need to go more deep in that. If you go, then it will take more time and you will get confused also. You just remember only the formula for effectiveness. If they give you only the temperature, there are two formulas. One is TH1 minus TH2 by TH1 minus TC1. This is one formula. Okay, where the numerator is the actual heat transfer and the denominator is the maximum heat transfer. Denominator will be same for both the cases. This is the case number 1. I am considering this equation to find out the effectiveness of the heat exchanger. Where TH1 means what? Temperature of the hot fluid at inlet. TH2 is what? Temperature of the hot fluid at outlet. Then what is the TH1? TH1 as we have seen already. TC1 is temperature of the cold fluid at inlet. Okay, so that all the values are given. You see, the counter flow heat exchanger, hot gases means hot fluid, enters at 250 degrees Celsius. So this is TH1. Leaves at 100 degrees Celsius. This is TH2. Okay. Cooling air enters at 50 degrees Celsius, leaves at 80 degrees Celsius. This is TC1. This is TC2. Okay. Then what is the formula? TH1 minus TH2 by TH1 minus TC1. Then you substitute all the values. You will get the answer as 0.75. So you check whether the 0.75 is given in the option or not. Yes, 0.75 is given. Suppose at the beginning, instead of this formula, you have selected this formula. Then you check the answer. 0.15 you are getting, but 0.15 is there in the option? No, 0.15 is not there. Then what formula you have to choose? You have to choose this formula. Okay, so that either this formula or I am not telling both are same. This is 0.75, this is 0.15, but you have to cross check the answers with the given options. What is your answer? If you are getting the answer with the given answer is same, then what you solved is correct, what formula you taken is correct. Okay, suppose your answer and given option is not there, then you have to change the formula and again you check the answers with the given answers, then that will be available, then that formula is applicable for this question. So there are two formulas to find out the effectiveness of the heat exchanger when they give only the temperatures of the hot fluid and cold fluid. What are the two formulas? First formula is Th1 minus Th2 by Th1 minus Tc1. Second formula is Tc2 minus Tc1 by Th1 minus Tc1. Okay, that's it. Fouling factor is not available in your syllabus, but just you remember, fouling factor formula is 1 by U1 minus 1 by U2, means overall heat transfer coefficient. In general you can say fouling factor is equal to 1 by U. So which is equal to increase the overall heat transfer coefficient, decrease the overall heat transfer coefficient, or equal to overall heat transfer coefficient, or 0. The fouling factor is, it's to decrease the overall heat transfer coefficient. Okay, next, for a double pipe counterflow heat exchanger, C is equal to 1, the effectiveness is equal to, when C is equal to 1, the effectiveness is equal to what? So that effectiveness already we have seen now in this, you see, effectiveness is equal to NTU by 1 plus NTU. This is when capacitance ratio is equal to 1. So this you remember. Suppose if they ask effectiveness, you have to solve by NTU. If they ask NTU, then you have to solve by effectiveness. So effectiveness is equal to NTU by NTU plus 1 or 1 plus NTU. That is the formula for the effectiveness when C is equal to 1. So this is the answer for that. Next, in a double pipe counterflow heat exchanger, 10,000 kg per hour of oil with specific heat Cp equal to 2.09 kJ per kilogram Kelvin is cooled from 80 degrees Celsius to 50 degrees Celsius by water of flow rate 8000 kg per hour and specific heat of 4.81 kJ per kilogram Kelvin entering at 25 degrees Celsius. What will be the outlet temperature of water? So this is a kind of heat exchanger analysis that we have seen in the lecture video. Is a kind of energy balance. Okay, what is happening in a heat exchanger? Hot fluid is going inside and it is losing its heat to the cold fluid. Hot fluid will become it will reduce, the temperature of hot fluid will come down and the temperature of the cold fluid will rise. Okay, so what is happening? The amount of heat lost by the hot fluid which is equal to the amount of heat gained by the cold fluid. Okay, so that equation you say. So normal general equation for Q is equal to mCp delta T. So heat lost by the hot fluid is equal to heat gained by the cold fluid. So heat lost by the hot fluid is mH Cph T2 minus T1, where T2 is the exit temperature of the hot fluid, T1 is the entry temperature of the hot fluid, mH is the mass of the hot fluid, Cph is the specific heat of the hot fluid. Similarly, mC Cpc T2 minus T1. Okay. Next, here mass value always you have to take in the unit of kilogram per second. Okay. So, but it is given in 10,000 kilogram per hour. You just divide by 3600 into Cp, specific heat also given for hot fluid. Cp is equal to, for hot fluid it is given a double pipe counterflow heat exchanger 10,000 kilogram per hour of oil. Okay, which is cooled from means then oil is the hot fluid. It is at some heat it is cooling. Okay, that's why oil I have taken as a hot fluid. Hot fluid mass is 10,000, specific heat is this much, and specific heat always we should take in the unit of joules per kilogram Kelvin. Okay, and mass you have to take always in the energy balance in terms of kilogram per second, so that you will get the Q value in the unit of watts. Okay, now I have taken the mass and specific heat of hot fluid and the temperature difference which is cooled from 80 degrees Celsius to 50 degrees Celsius. Similarly, for cold fluid also all the details they have given instead of exit temperature. So here they are asking us to find out the exit temperature of the water. Here hot fluid is oil, cold fluid is water. Okay, so by doing this energy balance, except this T2, I will know everything. If I substitute all the values in the formula, so that I can find out the exit temperature of the cold fluid or water. So I just substituted, simple calculation only. After that I am getting the T2 is 43.68 degrees Celsius. So the answer option is given as 43.75. So this type of problem also so many times they asked in the previous year question papers. Okay, next. If NTU is equal to 0.5 in counterflow heat exchanger, find effectiveness. So as I have told you already, if they give you NTU value, then you have to use the formula, effectiveness formula. So effectiveness is equal to NTU by 1 plus NTU. So NTU is given, which is 0.5 by 1 plus 0.5, 0.5 by 1.5 equal to 1 by 3. 1 by 3 means 0.33, right? Next. Overall heat transfer coefficient is given as 1000 watts per meter squared Kelvin. Area of the heat exchanger is 2 meters square, and logarithmic mean temperature is given as 32 degrees Celsius. Find out the heat lost. Okay, in heat exchanger during energy balance also we have seen. If you watch my previous video, you will see that this equation I have written in that Q is equal to UA into delta T or LMTD. So here they are asking only the Q. Okay, so what is the formula for heat exchanger analysis? Q, total Q is equal to overall heat transfer coefficient du, this is UA into LMTD. So here they have given you everything. So overall heat transfer coefficient means U into A into delta T. If you substitute, you will get the value of 64,000 kilowatt, then that is 64 watts. Okay. Next, the unit of fouling factor. Fouling factor unit is, it is not available in your syllabus. You just remember fouling factor is equal to 1 by U. Okay, so U unit is watts per meter squared Kelvin. So the reciprocal of that is fouling factor. So meter squared Kelvin power by watt is the unit for fouling factor. Next, two fluids, heat capacity C and C2. If C1 is greater than C2, find NTU. So what is the NTU formula normally? UA by C minimum. Okay, in the denominator C minimum is there. Here C1 is also given, C2 is also given, and stated that C1 is greater than C2. Then what is the minimum one? So the answer is UA by C2, not A. So that answer formula is UA by C minimum. Here C1 is greater than C2. So which one is minimum? C2 is minimum. So UA by C2 is the answer. Okay. Next. Area of the heat exchanger parallel 2 meters squared. Area of heat exchanger for counterflow is 4 meters square. Then you have to find out the LMTD ratio for parallel flow to counterflow. So area of the parallel flow heat exchanger area is given, counterflow heat exchanger area is given. You have to find out the ratio of LMTD for both parallel flow and counterflow. So LMTD for parallel flow to the counterflow is equal to, what is the formula for that? UA into LMTD parallel flow is equal to UA into LMTD counterflow. Okay. Now you just take LMTD parallel flow divided by LMTD counterflow. Here what is remaining? Area of the counterflow by area of the parallel flow. Area of the counterflow by area of the parallel flow. Area of the counterflow is given as 4 meters square. I think here it is not clearly visible. I am just reading. It is given as area of the counterflow heat exchanger, which is given 4 meters square. Area of the parallel flow heat exchanger is given as 2 meters square. Here it is coming AC by AP, where AC is the area of counterflow heat exchanger, AP is the area of the parallel flow heat exchanger. So 4 by 2 means 2 by 1. Answer is 2 by 1. Okay. Next, if effectiveness is equal to 0.5, find NTU in the counterflow heat exchanger. As we have discussed already, if they give you effectiveness, then you can find out by using this formula. Effectiveness is equal to NTU by 1 by n plus 1 plus NTU, but here they given effectiveness. So if you use NTU, then you will get the formula of effectiveness over 1 minus effectiveness. If you substitute the effectiveness value in the equation, you will get the value of NTU of the heat exchanger. So these two formulas are important. If they give you NTU, they will ask the effectiveness. If they give you the effectiveness, they will ask you the NTU. Likewise, they will ask at least any one question from this topic. Okay, here they asked you to find out the NTU. See what they given? They given the effectiveness. Suppose if they give you NTU, then they will ask you the effectiveness. So these are the types of problems, different types of problems that have been asked in the heat exchanger topic. Okay, thank you.